Thank you, Your Highness, the many excellencies, and honored guests. I am honored to be part of this extraordinary gathering. I want to take this opportunity to talk about an aspect of climate change that doesn't receive nearly enough attention: how we feed ourselves. On May 9th, 1934, at the height of the Dust Bowl in America, a massive storm swept across the Great Plains, lifting millions of tons of parched soil into the sky. 2 days later, the cloud reached Washington, D.C., darkening the skies, reducing visibility to a few feet, and filling the nostrils of our legislators. The message that nature was sending was unmistakable. If we didn't change our farming practices, our land would fail us. And the government responded with bold new policies to protect the soil, reshaping American agriculture for generations. Today, a similar cloud has formed, not of black soil, but of invisible greenhouse gases like carbon dioxide, methane, and nitrous oxide. Agriculture is a major contributor to the problem, but it also holds a key to the solution. Now, for most of human history, agriculture relied on the free energy of the sun and the labor of people and animals. For every calorie of fossil fuel energy used on the farm before World War II, a farmer was able to harvest 2.3 calories of food. But after World War II, fossil fuels transformed farming. We mechanized labor, synthesized nitrogen fertilizer, and built a food system more dependent on oil than sunlight. Today, it takes 10 calories of fossil fuel energy to produce 1 calorie of food, and far more in the case of meat. In a sense, we are now eating oil. The consequences for the climate are profound. Food production is responsible for somewhere between 20 and 50% of global greenhouse gas emissions, depending on how it's measured. This includes carbon dioxide from plowing, machinery, transportation, deforestation, methane from livestock and manure, nitrous oxide from synthetic fertilizers. Here's a key fact. 1/3 of all the carbon that humanity has added to the atmosphere was once in the soil. Much of it has been released through plowing and intensive farming practices. Take nitrogen fertilizer as an example. It's made using tremendous amounts of fossil fuel energy, and much of it never reaches the intended crops. When excess fertilizer gets wet, it turns into nitrous oxide, a greenhouse gas far more potent than carbon dioxide. Animal agriculture also plays a big role. Cows belch methane, and untreated manure releases even more. In fact, livestock alone accounts for 10 to 18% of emissions worldwide. Want to know the single most important step you can take to shrink your climate footprint? Stop eating beef. But agriculture doesn't just contribute to climate change, it's also uniquely vulnerable to it. Rising temperatures, shifting rainfall patterns, droughts, floods, and extreme weather are already disrupting food production. Scientists used to think that rising CO2 levels might help crops grow. Plants eat carbon dioxide, after all. But recent studies under real-world conditions tell a very different story. The IPCC projects a 2% decline in global crop yields per decade starting in 2030, even as the world's population grows and food demand rises. So the dominant model of industrial agriculture has excelled at producing vast amounts of cheap calories, it's true. In fact, far more than we need. But it is also a very brittle system, highly productive only when conditions remain stable. It depends on steady supplies of water, fertilizer, pesticides, and capital. And in an age of climate change, stability is the one thing we can't count on. In the future, resilience will matter more than efficiency. Studies have found that diversified farms with healthy soils fare far better in extreme weather than large monocultures. For many years now, the Rodale Institute in Pennsylvania has been comparing organic and conventional corn and soybean farms. In normal years, conventional fields often yield 10 to 20% more, but in drought years, the results reverse, and the organic fields produce 31% more. Why? Because their soils contain far more organic matter, which hold water like a sponge. Those same soils also handle floods better by absorbing more water without eroding. So healthy soil protects both plants and farmers from extremes. Now here's the hopeful part. Agriculture can do more than just reduce its emissions. It can help roll back climate change by sequestering tremendous amounts of carbon, pulling it out of the atmosphere, and storing it safely in the soil. Remember, a third of carbon humanity has released into the air was once in the soil. That's not just a sobering fact, it's an opportunity. Here's how it works. Plants capture carbon dioxide through photosynthesis and send up to 40% of that carbon down into their roots in the form of sugars. These sugars nurture soil microbes, which in turn supply nutrients to the plants. When the soil ecosystem is healthy, much of this carbon ends up locked in stable organic matter, where it can remain for centuries. Modern farming has disrupted this natural process through heavy tillage, erosion, and chemical inputs, which kill soil microbes. But experiments have shown how quickly soil health can be restored. Adding compost, planting cover crops, perennials and hedgerows, and practicing rotational grazing all build soil carbon. Imagine if we reshaped our farm policies, as we did in the US in the 1930s, to reward farmers for building soil, not just preventing erosion, but actively fighting climate change. California is already doing this. Under its climate law, ranchers can now receive payments for sequestering carbon through practices like compost spreading and rotational grazing. This kind of policy is unusual because it requires no trade-offs. Building soil improves fertility, boosts yields, retains water, reduces erosion, and captures carbon all at the same time. Think of it as a form of geoengineering with no downsides or risks. Most environmental solutions force us to think in tragic zero-sum terms. For humans to gain, nature must lose, or vice versa. But soil-centered agriculture flips that script. When we focus on capturing carbon through photosynthesis and healthy soil practices, everyone wins. At the end of the season, we don't just have lower emissions, we have more fertility, more water holding capacity, more resilience, and more food. This vision offers something just as important as ecological health. It offers hope. It shows that humans can work with nature rather than against it, regenerating the land and protecting the climate while feeding ourselves. Thank you very much.